So this is my task 5.4, the HD task. Basically I've just taken what I first developed in 5.3 and I've made a few modifications. One of the big things is that instead of using doubles for recording time, I've changed to integers. I noticed that there was some problems with comparing operators. Basically, some accuracy was lost and it was causing some problems. The other big change that I've made is that the amount of variables we had to keep track of was increasing. So before I just had three, I had a result variable that some would implement for themselves, a delay, and a delay timer variable. Now we have like more than one result we have to store, and we have to be able to get an average from that, and also keep track of the maximum amount of turns a player has, and also a result for each turn. So basically, I created a class that I call Blackboard. So the reason I call it Blackboard, I'm not sure if this is a technical definition or if this is just something that's slang in game development. But I know that with Unity Engine, they have finite state machines and they have what's basically a data container that's called a blackboard. So basically everything that's like basically goes between one state to another is stored in this blackboard class. Um, yeah, so it's all just here. Results are stored in a list. Um, Game max keeps track of how many turns. I didn't hardcode it to 3 because that could change down the track if this was a real app. So delay timer and delay is still there. So basically, to get the average, just do this simple function here. Yeah, so with the display result class, we keep track of whether we've reached our maximum amount of games or not. I also had to add another state called display average result, and as I mentioned before, everything's stored in ticks now rather than trying to convert to actual seconds because the doubles weren't going so well sometimes when we use comparison on them, like equals. So basically, yeah, I guess I'll show that it actually works. So we insert a coin here, nothing happens. So the big change here is that if you wait 10 seconds as instructed, it will go back to the insert coin. There you go. So let's do it properly now. Insert coin, go. What are the other big changes? Oh yeah, I'll show you that you get 3 turns. Ah, I have an error here. That's why it was taking so long then. Just notice that now. So that's all fixed up. Shouldn't take so long this time. There we go. 1.27, 8.9. Oh, I'll show you how to break it too. So there you go, we broke it. So we'll have 3 goes all the way to the end this time. That'll give us an average. Average is 42. We can wait 5 seconds and then it will bring us back to insert coin. So there's one other possibility here. Oh, the other thing we can do is we can skip at the end. That's all I want to show once we get our average up. Right, so we can skip the average. There we go. Yeah, so those are all the different possibilities and that shows that they'll work. So I guess because of that error before, I'll just make sure I don't have that in this testing class. Where was it? I just saw it. Too many zeros here. Make sure I save the fix for both. Alrighty. So what we'll have now is... I'll show you the testing. So we can see that all these tests passed. I made these tests myself. Basically, each one of these tests, what it does is I've created a bunch of different scenarios to try and cover all the angles. So, a situation where a user waits too long to press go after inserting a coin. So, a user gets 10 seconds on the 10th second when they're prompted to press go. It'll bring them back to the insert coin. So this is exactly 10. Yep. And if it were 99, 99999. Yep, just like we thought. Alright. A situation where the user presses go while they should still be waiting. So this is the part where you insert the coin, you press go, you get the wait option, and you don't wait long enough, and then you push go. So C, D, E, F covers that. Just as you'd expect. So they're meant to wait 1.3 seconds and they wait 1.2. A situation where the user takes more than 2 seconds to press go during the reaction test. So in this situation, the random number of 130, so that's their delay, 1.3 seconds. They push go, they wait, it's 130 seconds. And they wait, get 2 seconds. So yeah, it will display the 2 seconds because that's the maximum amount of time that they get, so that's the default if they wait too long. A situation where the user presses go after 0.4 seconds during the reaction test. So random time, 110 seconds. They push go after that time. And yeah, they get their 0.4 second display. A situation where the user completes the game 3 times and waits 10 seconds during the average display. So they start the game, have a random wait time of 243. They get a result of 70 on their press go. Turn 2, wait time of 100. They wait long enough and they push stop after 49 seconds after having, 0.49 seconds after having waited for the wait to finish. And in this situation, it's their third go. They wait 187. They have a delay of 187. They 0.67 of the second. They enter their result. Displays for 3 seconds. This one displays for 5 seconds. The average. So is that average correct? What do we got? 0.7 plus 0.49 plus 0.67 divide 3, 0.62, correct. A situation where the user completes one turn but presses go too early on the second turn. So on their first turn, they have a random delay of 1.63 seconds. They push go after 25 seconds after having waited long enough. All's well. And then on their second turn, they're meant to wait 1.92 seconds, but they only wait 0.6 seconds. And then it knocks them out of the game. So yeah, that's pretty much it for that bit. I'll also show the diagram I've got. So, sorry, wrong one. Basically, I've got a similar diagram to before. I've just taken in the fact that I'm recording everything as their ticks rather than seconds. Before I submit this, I've noticed I got one error in this, but I'll fix it up. Delay timer should be divided by 100 on display. In fact, I think this should be divided by 100 as well. But yeah, other than that, it's very similar to what it was like before, just had to add the average result, and we've got the connection between here and here now, where display result can end up going back to random delay. So yeah, that's pretty much the end of this task, and I'll fix up that diagram before I submit. Okay.